Okay, so the third example for the relative velocity equation is going to be about the four-bar mechanism, as we can see in this diagram. So just remind you about the four-bar mechanism. What you can see here actually are three links. So the four-bar is going to be actually the ground. So it's going to be something between the D and the A. In this mechanism, we know that the angular velocity of the link CD is given as 4 radian per second to the anticlockwise direction. The length of that link is equal to 0.4 meter, and this link is actually rotating around a fixed point D that has a velocity of 0 because it's fixed to the ground. So at this instant, we have that the link is vertical, and that means its velocity at the point C is going to be purely horizontal because it's going to be perpendicular to the link of the CD. What you can see is again to go from the right to the left, and this means that this value is going to be negative. However, that's what we're going to prove as we go. Now, as we go to that link is going to have two velocity at the point C and velocity at the point B. To know the direction of the velocity at the point B, we need to actually go to the link AB. So once again, this velocity is going to be perpendicular to the link AB. And thus is going to have two components, one to the x direction and the other to the y direction. Okay, so now we find the C, we can find the direction of these two forces, the I and J velocities, and the I and the J scalars, and we know the length of that thing is 1 meter. To move from the C to the B, we need to move from the right to the left, so it's going to be a negative value. And the omega of the BC is unknown. So we're going to have three unknowns, and they're going to solve for that to find the velocity at the point B. And then we're going to find what will be the omega of the link BC. Take the velocity the VB, this one. Okay, and then we just divide it by the length of the link BA, and we can define what will be the omega of that link. So we're going to start doing that. The first thing we need to do is just separate the three links from each other. We start from the first link, as we mentioned earlier, again to find the velocity VC. So again, if I can to write down the relative velocity equation, I can say that the VD is equal to 0, and that 0 is going to be equal to the VC, okay, plus the omega multiplied by 0.4. That's K, and that's J. So we'll come to the fact that the VC is equal to negative 1.6 meter per second. Okay, so next step is after we're getting this velocity, we're going to take it to the other link here, as you can see, and write down the relative velocity equation for these velocities. This velocity is going to have two components, the x and the y. Both are negative because one is going to go downwards, the other one is going to go to the left. And we're supposed to have an omega BC here, and should be multiplied by the negative 1 meter. We're going to get the equation for that and solve for the unknowns. So we start with the known that we have. We have 4.4 meters. We have the 4 radian per second. We have 1 meter for the length BC, and we have 0.5 meter for the length AB. And we know the triangle that tells us what is the direction of the length AB is also given. So we start with the CD that's subject to a rotation about the fixed axis, and the velocity of the C now can be found by simply multiplying the omega CD by the length of the RC/D, and this will be equal to the 4 multiplied by 0.4, and this will make it 1.6 meter per second. Now we've done the first part. We're going now to the link BC to write down the relative velocity equation for that link. So we can see now we need to find the two components of the velocity b. Okay, we can use this triangle as I mentioned earlier to find the direction of the two components we have for that velocity. Velocity c is going to be just in the x direction, so it's going to have a negative 1.6 I. The omega bc is unknown, but it's rotating around the z-axis, so it's going to have denoted by k. The rbc is only 1 meter, and it's going along the x-axis, so it's going to be -1 because we're moving from the right to the left to reach the point B. So it's going to be -1 I. So that's what we're going to write down. The velocity B is going to be negative 4.4 over 5 VBI plus 3 over, sorry, this is minus 3 over 5 VBJ. Now negative because both are going to be downward and to the left. Now the omega BCK multiplied by -1 I is going to give me negative omega BCJ. Now just take everything and stick it in the equation above. We're going to get that equation. Now you can separate the i's in one side, the j's on one side, so we can start with saying that the minus 4.5 VBI is equal to negative 1.6 I, and we can find that the value of the VB to be calculated is going to be 1.6 divided by 0.8 because this value is 0.8, and we're going to end up with the velocity VB is going to be equal to 2. Okay, that's it. Then we're going to have this one equal to 2 multiplied by 3 divided by 5. The omega BC is going to be equal to 1.2. Okay, so that's what we've done. And by solving for these two equations, we come out with the VB to be equal to 2 meters per second, while the omega BC is going to be equal to 1.2 radian per second. So these are the answers for this part. Now I know the VB, and I will go to the third link here. I know the VB, I know the length here. So the omega AB is going to be equal to the VB divided by the length AB, which is 0.5, and this will make it 2 divided by 0.5, and this will make it equal to 4 radian per second. Okay, so simple as that. It doesn't have to be too complicated. You only have to follow the correct sequence of the solution, and you will get the answer directly.